we're going to go to a set of videos that we have. And these are specifically focused on our macroscope makers, and they come out of a series of interviews that I've done with macroscope makers in the past year. When COVID hit and forced everything online and socially distant, it actually opened up a great way to have Zoom interviews, where in the past we may have not done that or done a phone interview or had to go there. This really gave us access to a number of different people and could do interviews more or less informally through the Zoom. And so there's some of these here, and they'll also be talking a little bit about their work, important methodologies that they use, tools that they use, algorithms. And so I hope that you will enjoy these, and I'm just going to share my screen here.
I sort of put myself in a potential reader's shoes of like, you can either do a really specialized piece that's specifically for subject matter experts, or you can kind of take a step back. And that's what I did. And I was like, well, this stuff is all really interesting to me as someone who is, just a curious person. And there's so many different aspects to it that I think this would work nice as sort of a broad explainer kind of piece. And that's where I started exploring the visual essay type of format, and thinking about the different entry points, the different ways I would move from section to section, and going from a, let's start with a simple kind of chart to sort of outline what the problem is, and then move into a geospatial kind of argument where you're looking at different specific places and specific problems, around the US, and then sort of finally ending that with some kind of, although it might be unsatisfying, right, because this problem is huge, some kind of conclusion that shows different levers that you can potentially pull to affect, water scarcity and water stress and conservation efforts in the country. I think this is one of those cases where a lot of the material kind of spoke for itself, and specifically the data. You don't want to be too persuasive in that you bring yourself into the project, right? No one should really have to think, you should want context, and you should want to know where these data sources are coming from, who is presenting this information to me. But it is less of a like personal argument about like, this is how I think we get there. And I think that's where I ended up with this, there are personal behaviors that you can change as a collective that could potentially conserve water, but then there's also areas where we need clear government intervention or, huge private, funding to be able to tackle challenges like, infrastructure. What if we had a huge infrastructure bill where we fixed all of our water infrastructure resources? Or what if we, became more efficient with irrigation? And by being able to play with those directly and see and compare the different changes in there, you are sort of building the argument for yourself. I'm just sort of providing the calculation and, the visual design to invite you to do that. When you go through the piece, you're looking at a line chart or an area chart, and you can get like tooltips to know like specific points in time, what were these water levels at? Or, as you go through the geospatial analysis, right, you can look at, what, specific, infrastructure expenditures might be necessary based on, an EPA assessment. But once you get to the end, like, that's when I force you to actually, explore. You have to explore to get some answers there, right? So depending on how you interact with it, you're going to walk away potentially with a little bit of a different viewpoint than someone else might, but they're all correct because this problem is so big, there isn't one answer. And that's kind of why I resolve it at that moment there. When I build this kind of stuff, right, I really believe that like the onus is on me. It's not on the reader, right? If someone walks away with the wrong information, that's because I, as a designer, or as a developer, or whatever role I was taking in the project, right, I didn't do a good enough job of explaining something to someone. And because of this topic was so dense, that's why I was like, you have to interact like by literally scrolling, right? So you force someone to engage right away, but they're not controlling the narrative yet. You only give them that control at the end when you trust that if they experienced the information and learned what I learned doing all this research and then sort of synthesize and show you in the first two parts, then you know enough to basically make a responsible, draw a responsible conclusion. One of the benefits you get from working on an election is you know when it's coming, right? You know, every 2 and every 4 years is a midterm and a general election. You can start ahead of time. So really early on, we started in the design process. It was one of the first ideas that I brought to the table was using a cartogram for a map instead of or in addition to a normal geographic map that doesn't distort the areas and instead presents presents each state sized according to the number of electoral votes they have, which makes it a bit easier to look at the national map and know, by seeing the balance of blue and red. But anyway, that design process and all those iterations were done in just design software and Sketch, right? Early on, it was just, meeting with editors and reporters, people that are experts, people that have worked in visuals on this kind of stuff before, working with our cartographers as well, right? And just thinking of all these different ideas. And there's probably, 100 different ones that never even made it, that saw the light of day. They're just stashed away in design files, right? But that's sort of the way you have to do it. And that's sort of the theme of our conversation here. Is like, when you have the time, this isn't a breaking news story, right? Obviously, there are results that are breaking news, but we know it's coming. So there were a lot of meetings, a lot of just like, worrying about the micro interaction, all the little details, working on every single platform, right? On the smallest phone, in our native app, all the way through. If someone wants to pull up our live results page on a projector or something, it'll still work. It won't break, right? One of the benefits you get from working on an election is when it's coming, right? Every 2 and every 4 years is a midterm and a general election, right? So you can start working on things ahead of time, right? This election, or a pandemic election, is unique in a lot of ways, but the rules are the same, right? There are electoral votes. There's each state has a certain number of electoral votes. You might want a map, you might want some tables, right? You know kind of what the candidates are, what Senate seats are available, which ones are up for election, which ones aren't, right? What are the rules about when something goes to a runoff, right? How are, Maine and Nebraska, they're different in their electoral allocation, right? There are all these kind of like rules basically. And again, that's like the sort of the subject matter expert, the curiosity. You need to be able to like understand exactly what the parameters are for a US election to be able to present the data, in the right way, right? Designing and planning for the data, there's a range of data that could possibly come in, right? Even if we're surprised that a candidate got more or less of the vote than we thought they would, the design still works regardless of that, right? And in other data visualizations, you have to really worry about that. That could affect your scaling depending on what kind of chart you're using, right? And we obviously had a test with a lot of fake data, but just knowing the possibilities, the boundaries, right? No one can get 8,000 electoral votes, right? The boundaries, the rules, everything. So being able to make it work in the most extreme cases allows for a lot more control and a lot more like, well, we know it works in this weird case and that is really uncommon, but it's possible, right? And we know it works in a more like common case that we've seen play out. We even have designs that no one ever saw that were, what happens if there's an electoral tie, right? What happens if like all these kinds of things? What happens if a state never reports their vote totals, or something breaks down, we don't get votes that we expect it to? There's different ways the map reacts and the designs react, and a lot of those weren't actually used. The way the election played out was it was slower counting than normal, right, which we expected, but there weren't necessarily any like data related surprises. Meaning like there were no data structure issues. Our API that we use for the Associated Press, everything worked really smoothly there. They were able to report and even give us a heads up when they heard that counties and states were going to be reporting new data. So we definitely felt like, all of the testing that they did, they tested their API, of course, with, the people that are going to subscribe on election night to be able to test all of their designs with their data structure and the way that they're going to be reporting things. Having all that planning in advance definitely went a long way, because we were pretty much, aside from a few things, we were pretty much able to kind of just sit back and watch the graphics kind of populate with data.
every time you try to translate the information in a visual experience, could be a complicated visual experience like a network, but it's still a form of simplification. So simplify complex information is good by definition, because is a form of democratization of knowledge. So this type of tool can improve at the end democracy, for example, or can improve the way that people manage money, can improve the way that people choose leader. So if we have a correct way to share information, and we have so we try to extract information from meaningful resource, and then we have a simple way to share this information, we can engage almost everybody to really understand the complexity of reality, and then make the right choice. A system like Facebook, using this flow of news with the main goal to push you to stay there and look more advertising you can. So because this is the goal, they needed to entertaining you. And a way to entertaining person mean push you to read something that you believe is true, push you to read something that other friend in your community believe is true. And in some way they enforce the bubble. They at the end they create this polarization of idea and the merging of very interesting idea like flat earth, again, after so many centuries, after Galileo, after Copernicus, again, we talk about that. So when you have approach like a News Explorer, so many other interface where the goal is to share with you in a very clear way interconnection between news. We don't oversimplify reality. We don't give you what you want. We just give you an overview of any type of source that are available. You can really understand by looking this interconnection how the system works. We build another tool, for example, where you can really understand quickly community of people that always cite each other. So that they create kind of an invisible university, or community. They always agree or move or research in some direction. In the news is the same story. There's a group of journal, television, they always propose the same type of vision, interpretation of reality. So you can see this type of information or pattern emerging with network visualization. So complexity emerge visually and can be scared, but this map is not so complex like the real world. It's always a strong form of simplification. So reality is complex. You need to push yourself to understand what's going on. And this is an effort that you cannot avoid if you really want to make the right choice everywhere, in economy, in politics, everywhere.
We were actually faced with a problem unrelated to news. We were trying to deal with the collection of TED Talks that there are. There's thousands of talks. At the time, there were over 2,000 of them. And the question was, how does a user navigate the space of TED Talks, given that a user wouldn't know necessarily what topics were covered by TED Talks, what topics were there. They couldn't just do something like a search. So we envisioned a way to arrange the available talks such that the related talks were close together and talks on different topics were further apart. And we wanted to provide a navigator so that you could go to the area that the topics of interest were located for you. And then we were hoping that what would happen there is people would discover talks by serendipity, because talks near the talks that they were directed to would also be of interest to them. So that was, we had access to the transcripts of the TED Talks initially, and IBM had just acquired the Alchemy company, which was doing natural language processing, and we used that to extract concepts from the talks. And so based on the concepts that were found within each individual talk, we envisioned a high dimensional space within which these talks were located, and then computed the distances between them and used that as a basis for laying them out in a two-dimensional space where people could navigate around them. That had a successful outcome, and we realized that the approach wasn't limited to just navigating talks, and could in fact be used to display and navigate any collection of documents. And about that time, Alchemy came out with a news service. And so it was natural for us to apply a similar approach there. And that was the beginning of the News Explorer. That time, we didn't just extract and display concepts, but also entities representing the people and organizations and companies and locations that were found in those articles. And we connected them together in a network, which had the same effect of locating related items close to each other. And then we extended the visualization with a timeline and a geographic map, and loosely linked all the visualizations together so that events in one of them would affect the other ones. So you could use them to navigate the articles that had the similar locations or were all about similar concepts or entities and so forth. And finally, we added a homepage that gave a sense of what's going on and an overview of the news, and provides a variety of entry points to dive in and start consuming information. Natural language processing just deals with the text, and it can do things like summarize, detect entities, relations between words, extract concepts or themes, determine sentiment, and even in some cases answer questions based on a passage. The Alchemy tools we were using were incorporated into IBM Watson Discovery API. In the Alchemy News Service, they're providing the information from the news articles. They're extracting those entities of different types: people, companies, organizations. We get that information about which entities have been extracted associated with and which concepts and what sentiments have been extracted with each article, and that's how we build the network. We take that information on an article basis and then reorganize it internally on our server to build a network that contains entities and articles, not just articles with a list of entities associated with them, and we link them all together, and that network is the basis of all the visualizations that are part of News Explorer, and they're just different visualizations taking that network and displaying them in different ways, and that's how they can communicate with each other about what they're looking at.
Well, I think first of all, it was my own curiosity. And you probably know Hans Rosling and his Gapminder project. Mm-hmm. So I was really impressed with his work. And previously I had worked with T-SNE for quite a while. And I was thinking for a long time, like for a year or a couple of years, how great could it be to get that data from Gapminder, feed it into T-SNE, and just see what we get. Like, I didn't know what to expect. I was just curious, like that kind of scientific curiosity when you want to see what you can get when you use some scientific technique. And then we just found that project, that competition, and I thought, wow, that's exactly that data I wanted to try. And I really wanted for a long time to submit a project to the Information is Beautiful Awards. So we kind of discussed in our team internally and decided to build a project. I think the biggest challenge was actually to polish everything up to the level so it can be presented. We have worked previously with technologies like T-SNE. We did a lot of data visualization. So we knew how to build that. But we did not know how to make a project that can be shared with everyone, like a data journalism project. We almost never did that before. So that took us a while to understand how to tell the story, how to present the data, and to find the story. Because first, when we just applied the algorithm to the data, there was no story. Like, we had to go and explore and find interesting things in that data. Yeah, we really wanted to make that part. Of course, in the first prototype, we didn't have it. But then I was thinking, how great would it be to have this feature so you could change the parameters and see if a country can move to another cluster, for example. And that gives you that thought that you can actually change something, and that will change change the country, change the life in that country. So, and that became like some kind of a game. It's very playful, like you can just drag the sliders and see the flying dots around. And a lot of people were really interested, like, what should you do in my own country so it can become better? And I think that's great. Like, that's what I like a lot in this project. And we were very conscious when we were working on that. We really thought that it's like the key component. Like, the project would not be as good as it is if we didn't add it. Our project, our data-driven country map, shows you that you can do fun and interesting and beautiful, to some extent, stuff with data that inspires you to study and work on similar projects. I don't think it can work as a standalone tool, but it definitely shows you that you can extract a lot of information from data with new technologies. And then if you like that, you can go further and explore it by yourself and like go deeper, do your own data analysis, other data visualizations, and so on and so forth. What we do technically, we reduce the amount of dimensions. So initially, you can say that if one data point is described with 100 different metrics, then you can say that it lives in that 100-dimensional world. So what algorithms like t-SNE, and there are other algorithms like that, does, it reduces the amount of dimensions. Imagine you have a country, in our case, let's pick a country, and then that country can be characterized with a variety of different metrics, like GDP, population, surface area, and so on and so forth. So you can have hundreds, maybe thousands of them. Then you have many countries and have many metrics that characterize these countries. And you can feed all of that like as a huge matrix, as a huge data frame into t-SNE, into that algorithm. And it will just read the data and it will try to find similarities and group the points that are similar together on a 2-dimensional or 3-dimensional plot. So in our case, if two countries have some similarities, then you will find them closer to each other on that t-SNE map. And if not, then they will be somewhere in different clusters, in different areas of that map. You can see how, for example, when you open the project first, you have Russia and Brazil in the same spot, and you're thinking like, why they are in the same space? And then you can open the sidebar and uncheck the population and the surface area checkboxes, and that will run the algorithm again, and you will see how they split and go to different directions. And Russia comes to that former Soviet Union countries cluster, and Brazil goes somewhere else. And t-SNE just does that automatically. It doesn't know anything about the data, and it's not trying to do any categorization. So in our case, we knew what are the data points. We knew that they are the countries, and we were interested in finding where they are on that t-SNE map. But in many cases, you just don't know. You have some huge data set and you need to make sense of it. So you can feed it into t-SNE and it will form clusters. And then you don't know what are these data points, and you can start your analysis. You can pick a cluster, you can, for example, select a range of points, and you can explore what do they have in common. And then it's like a way how to explore your data set. That's one of the powers of such algorithms.
So the project sort of came to us. It was very open-ended. The Nature editing team reached out to Barabashi Lab and asked if we'd be able to make a visualization for the cover of their 150th anniversary issue. At that point, the idea of an interactive component was something everyone was interested in, but not definite. So we kind of internally started brainstorming like what possibilities to present them. And we went on their website. They have like a timeline page, this history of nature page. We made like this list of when all the editors changed, what, you know, so we could then compare it to the data and see if the editing staff like directly influenced anything about the magazine. There's a timeline already there about the history of the organization and infrastructure of the journal, but what the journal is really like a venue for the research. And there wasn't, besides like these highlighted papers that are like very famous, there were a couple mentioned, but there wasn't, you know, like a big overview of like a timeline of the work. So that, I think that's sort of what we managed to get all of the publication data from them, and then we decided to try to show all of that kind of in a few different lights, like, you know, over time. You know, we had Mauro Martino come in and he made the animation for the project. So the temporal dimension was like very important to seeing how it evolved, but then we also had the big network of once it, you know, of present day 2019 nature and everything that came before. And you could sort of see the different disciplines and the clusters of, it was a co-citation network. So it was papers linked if they were cited by the same paper. Then, I mean, we even split it into 2 visualizations as well. So then we pulled out like these 10 feature papers and looked at their development over time. And the idea was just to, you know, give a detailed view of the impact, the disciplinary breakup, and watch it grow also from the beginning. You know, making a still image is one thing, but making something that big interactive is really challenging. And even our process, like even generating a preview image of what, you know, we made renders, we made the animation, we made the interactive piece, and then, you know, trying to preview it before you spend all the computing resources to make a render was really tricky. There was all kinds of things like, oh, it just shows black until it's done, or, you know, when I zoom into it, it goes away because like the computer can't load it. And we had to resort to a lot of tricks to optimize it. I think the optimization was a really big part of the development of that project. But Alex did a great job helping with that. He was so helpful. That's yeah, Alex Gates, the researcher I collaborated with. It is really intuitive to click on it and be like, what's that? So I think, you know, with thought, okay, we'll make that a possibility, but just by looking at it, you know, what are you going to click on is probably the biggest nodes and the outliers. So then the search bar is the other thing that we added in, which is just people will probably want to look up anyone they know who had a paper or themselves. So I think, and then is sort of the second step is like, okay, well, you looked it up, you saw where it is, you saw its like, you know, size relative to other things and the discipline, but what else can be done? So then we have that list of subsequent, you know, co-cited papers, which that's kind of fun to hop around, I think, and I think that was a nice addition that we made. For me, you know, I work with a team of researchers who are putting in like a lot of effort to give me really big data, and it's, you know, cleaned and sort of we, you know, adjusted or normalized or scaled the numbers. So, you know, I feel like working with a team of people like that, I really want to do justice to their work. And I also, then with the data set being like everyone's research, for 150 years back with some of these like famous papers of like huge scientific discoveries, you really want to present it in a way, those and all of the people's papers who are like working today, who may like later have a really important paper, they're even, so it's like so many people are doing this agonizing amount of work, putting years of their life into it. And then it's like, we're going to show it. And then there's a search bar and they can look up their paper. And you just want to make sure that it looks, that it's presented in a way that does justice to the data. I think even back when I was working with illustration, I was, just on my own doing these like zoology kind of projects of looking up animals and drawing them and studying their taxonomy. And, my undergraduate advisor, she put me in touch with some people she knew that were in the science departments to sort of advise on that process. And then I actually ended up doing like journal cover for them. When I was studying game design at OSU, Jeremy Patterson, who had a split appointment as a UX designer at Nationwide Children's Hospital, reached out to me and a friend about doing some work for his team. And our first project was a VR game for pediatric pain management, which I decided to focus my entire study on. And it turned into years of collaboration on many projects. And we were always collaborating with doctors to use games or toys to try to make the patient experience better in a variety of really specific medical scenarios. And something that I've heard throughout all these years of different collaborations is that there isn't enough art and science collaboration, that it's kind of rare, but that it's really valuable. And I think, when you work with someone from another discipline, you get to share the best of each methodology. You get to bring in tools you didn't know about or have access to before. You can learn how to reach a wider audience, or you can maybe even like learn about a new audience that you didn't know existed before. Network science, particularly the field that I work with a lot now, is about connecting things. So it's a really good place for these kinds of collaborations. The VR collaboration with Nationwide Children's Hospital, that started when Jeremy Patterson, who had a split appointment as a UX designer at Nationwide Children's Hospital, reached out to me and a friend about doing some work for his team. And our first project was a VR game for pediatric pain management, which I decided to focus my entire study on. And it turned into years of collaboration on many projects. And we were always collaborating with doctors to use games or toys to try to make the patient experience better in a variety of really specific medical scenarios. One of them was for hemophilia patients while they're getting these infusions they need of this factor for blood clotting. That it's like a process that needs to be done all the time. It's a needle. I think it's very common for them to develop a fear of needles and become very nervous. Like they're all children. So sort of covering their eyes and having them do something else especially if it's like a game and it's like engaging and fun, works surprisingly well. I think on that project we had several sort of little built-in things to help further. Like we had a lot of very calm, kind of watery environments that were very peaceful. And we also had a little microphone attached to the bottom of the headset that they breathe into for some of the games, and sort of to keep them like breathing. I think one of the biggest challenges for working on someone who's like getting their arm stuck with a needle is that they cannot use their hands for any kind of controls. So like what we ended up doing was really relying on the breathing sort of as a button push, but then also almost everything is just you look around. So it's sort of like catch the item, or like, you know, look at something for a period of time, or, you know, timing how long you look at things, or timing your breathing, things like that. So that was sort of the interaction design of the game for people receiving infusions.
I'm kind of like an outside perspective to the whole field of scientometry and scientography. But my, if you want expertise, less expertise, maybe rather more than experience, comes from dealing with cartography and dealing with the globe as a format, as a medium, as sort of the ultimate macroscope. And for a long time now, for well over 30 years, I've worked with globes to have them represent issues, data, and realities that go beyond the geographical, beyond the geophysical, or the geopolitical, even though that was the original impetus for me to start the work. Because whenever I would see, oh yeah, there's a globe that claims to be geopolitical, for me, it turned out just having a few colors and a few lines there to delineate nations and states was very limited application of the power that a globe would offer. So this is kind of what I've engaged in for the last few years, few decades, if you want. And that started out with using little, 30 centimeter, 12-inch diameter illuminated globes. And then it eventually grew into a whole family, or if you will, like several generations of globes, more than well over 1,000, maybe 2,000, maybe 3,000 that were, let's say, consumed in the process of making the globe. So I think I'm one of the few people on Earth, maybe the one that has destroyed more globes than anybody else in the process of making globes. And I've collected like the better ones in a website that's called worldprocessor.com. And World Processor originally, anyway, is a name that I stole from an advertising campaign that The Economist had in the late 80s, because that was a time when the word processor was a cool thing. And then The Economist said, well, we actually need a world processor as opposed to a word processor. So I'm still getting a lot of sort of confusion on that word, and a lot of autocorrection in the wrong direction. So that led me to one of my last projects that was making dynamic maps, because normally the globes that I would do would consist of just a stable image. Then I made a couple of audio-visual globes that are even today they are shown at the Japanese Science Center and Museum Miraikan in Tokyo. So there's a huge globe called the Geocosmos. That Geocosmos globe is probably at this point, probably still the largest high-resolution spherical display on Earth. It's 6 meter or 20 feet diameter, and then the other side of it is that um, it has 10,000 tiles, little OLED tiles. So it has an amazing resolution, and it's very, very bright. So I made like basically like a 20-minute like animation for it that you can see from any point of view, but of course you always get a different story. There are other examples of the work that hark back to dealing with sort of finding hybrid geographies or hybrid representation of data. So there's another project that goes back a few years where I used digital elevation model data of the Pacific Rim, and I rebuilt the Pacific Rim, but as from the theoretical perspective of the dateline. So as if you would travel down the dateline and you would look left or right or east or west comparatively, you would see the horizon line. That's also assuming that the world is flat. So it breaks with a lot of assumptions that we have a lot of standards. But in order to do that, I was then making an image that was 4 inches or 10 centimeters tall, but something like 540 feet long. So for about 160, about give or take 160 meters, you could walk and walk and walk to experience that image. So for me, also the physicality of interacting was something of importance, and it still is, because I think there's always a user involved in experiencing something that's normally restricted to a two-dimensional screen. And I guess it would be my task, also within the context of this seminar, to maybe come from the perspective of somebody who has experience with people who use their body and their physicality to experience something, and to see how that can be brought into the equation, and if that is perhaps on one level adding to the intensity or the can't really quite say precision of the experience, but just adds another dimension to it in terms of the memorability, in terms of the depth, and maybe the way people process what they see and what they experience. That maybe is what it boils down to, that you can of course start with data, or you can start with an algorithm and say, what can we do with this, or what needs to be done. My sort of starting point would always be, maybe the data is correct, maybe the presentation is correct, but if the aesthetics don't work, then it won't have an audience. Now, I clearly come from as a representative or somebody who's trying to engage an audience that is like everybody, that is clearly lay people that would read a newspaper, that would surf the web, or that would go to an art exhibit. And as you normally go to an art exhibit, you don't really look for a particular type of information. You go there for a general experience, for something that, gives you like something ricochets off an idea that you have, or the other way around, that you get something out of it, that it tickles something in you that, hasn't been engaged in a while. So it's something much more fuzzy, but nonetheless, it is addressing something that we have as humans, in terms of an interest that sometimes we cannot even put into any kind of formula, or not even in words, in terms of that is what I want and that is what I don't want. So that's why we expose ourselves to these things. And so that would be my perspective. For me, my interest goes back to a very simple reckoning. So there's diplomacy, and then there's war, right? And then there's the old saying that war is a continuation of diplomacy by other means, or politics by other means, if you want. So I figured what we know about war and the kind of instrumentations that we have in terms of solving conflicts with military tools is incredibly advanced and well known, and has become so much part of our culture, so much of our preparation. Huge budgets goes into that. And we just go to the Pentagon budget versus the State Department budget. It's like 1 to 100. It's kind of amazing. But when you see all the wars that have been avoided by diplomacy, then you see there's an economic equivalence. You see, this is actually where you can save money. This is incredibly effective, and war not necessarily. And we see that right now in current politics, how difficult it is to end a war. And so coming out of this sort of almost like economical calculation, it's like one thing is very popular. We look at movies about it, but what was the last time that you've seen a movie about a diplomat or like a hero diplomat? Like Richard Holbrooke, there's like one documentary or maybe two documentaries. So there's very, very little about that. So there's a whole hidden side to that. But war is interesting because it is so telegenic, right? And it's also so visual. And then again, that is also what diplomacy lacks, sometimes structurally so, because it's all about being delicate, it's about secrecy, but it's also about very, very nuanced communication. But I've discovered that there's a whole underbelly of diplomacy that's actually highly entertaining and also highly sophisticated in terms of how protocol works, how table designs influence decisions, how even the weather and the landscape for, if you have negotiations in the mountains, how long do treaties last that do that? How long do treaties last that are at the seaside or at a lake? And what is the disposition that people have to have, and what kind of games are being played. Those games, I think, are sometimes highly interesting and also very entertaining. So in a way, I was trying to find a way to give a perspective onto the whole issue of diplomacy, so that maybe one day a kid will not say, well, I'm going to become a soldier or a policeman or robber or whatever for that matter, or a cowboy, but I'd say, well, I'm going to be a diplomat because that's going to be so cool. And I think there's enough material. The only problem is that this material, again, it's very hard to access, very hard to translate into an experience. And that is where I think, on the other side, data can come in, and maybe very good visualization would work to make that somewhat more tangible or experiential. There's something that was done in Paris, and it was a program that would analyze text and would create shapes out of that. And I think it's called Gargan Text, and it was presented yesterday. So it also has a really funny introduction in English, Latin, and French. Especially the French version is very funny, but also the Latin one is completely impossible to translate. So if you go to the gargantext.org site, you will see it at the very bottom. So that's the kind of thing that really engages me. And I say that very directly in correlation to what I'm interested in terms of having an enormous amount of documents that I cannot possibly all read, but have to get a handle on it. So I'm actually looking right now at a way to automate the like sifting through, not just by keywords, but by semantics, through literally a like millions of pages that I need to get access to, but it's just too much data for me. So it's a sort of a big data problem that I need to solve.
There we go. Sorry about that. As I said before, this production has not had any major hiccups or anything. It's been great, and a large part of the reason for that is Dave Cooley, who is monitoring everything here and making sure that things go off without a hitch. And we're just very very appreciative of that. And hello. And yes, and I want to thank Medina, my colleague Medina, who was our person on the scene for people who it was daytime for them, but it was the dead middle of the night for Medina, and she handled that just very well. And so thank you so much. Thank you to Andreas for his wonderful knowledge of lighting, camera angles, the best production values that you can get. And to Kati for her vision and for buying us lunch. And, this has been a wonderful experience. I can't believe that there's only a couple more hours of this. And we still got a lot of great things coming. We have the announcement of the contest. We've got a few science forecast clips that we're going to play, and all that's coming up. But I wanted to thank especially our presenters who gave up an hour of their time. I've said this to all of them. Thank you for giving up an hour of your time at a busy time of the year to be part of this. And there were some just really fascinating talks, and everybody that I saw, I came away with something that was extremely valuable. And so I want to thank them for just the preparation and for, taking over an hour for us. And so that was great.